My name is Vipul and I have 11 years of IT experience. During my IT experience, I have worked on multiple tools. So I started my journey from the Informatica data migration tool and then I moved on to the SAP world. In that I worked on SAP Data Services, which is again a data migration tool which is specific to SAP. And then I worked on SAP HANA 2.0 on-premise as well as SAP HANA on cloud. And after that, I worked on SAP Analytics Cloud, which is a reporting tool available by SAP. And it has a lot of great features available to us. And then after working in those technologies, I moved on to the Snowflake Data Warehouse and also MySQL. Apart from that, I'm also associated with Data Vision as a trainer for MySQL and Snowflake Data Warehouse. So let's get started. So today we are going to do a deep dive into the data warehousing concepts. So let us understand what all components we have within a data warehouse. It will serve as a refresher for you because if you are already aware of the multiple data warehousing concepts, then it will help you revise all the concepts. And if you are new, then you will learn a bit more detailed information about the data warehouses, how the different components work together. Okay, okay. So let us see uh, the data warehouse deep dive. Okay, concepts. Okay. So before understanding a data warehouse, we have to first of all have a transaction information. What is a transactional data? What is a master data, and so on. So understand all those concepts. Let us take a real-time example of any sales transaction. Okay. So this is a normal sales transaction. Whenever we go to a supermarket and we buy some things, the transactions like this are stored in the systems. Okay. So now let us say a person went to a supermarket at a specific time to buy some products. Okay, so I can say that okay, it's a Ram, any person can be okay. Ram went to store ABC in let us say in Chandigarh at 10 a.m. And he bought some products. Went to store ABC and bought 10 bought 10 red apples. Okay. So here you can see that this is any normal transaction whenever we again go out to the supermarket and we want to buy some products, then this is how the entire transaction looks like. Here we can see that we have all the details, when who performed that transaction, when that transaction happened, where that transaction happened, and what all different components we had related to that transaction. So now, out of this transaction, we have to first of all take out the different objects which are necessary to create this transaction. Okay. So here we can see that we have an entity. So first of all, we have to extract the entities from these transactions. So we can see, let us first of all extract them. So we have an entity ROM, we have an entity store ABC, we have an entity red apples, or I can say apples, and then we have an entity which is a place called Chandigarh, and then we have an entity 10M. Okay. So here you can see that without any one of these entity, the entire transaction will be incomplete. If we do not know who performed the transaction or who bought something, then the transaction will make no sense. If we do not know where that transaction happened, then again it will be incomplete. What was bought in that sale? Again, it is very important where it happens and when it happened. Okay. So where, when, how, and who. All these questions are answered using different entities. So now here, if you look at not just a data warehouse concept, but a general database and data storage mechanisms we have, over there we have something called as master data. Okay. So master data is a data for the which actually hold the entities data. So without the master data, you will not have the sales information or you will not have the transactional data. So here you can see that all these entities, because these entities are very important for a transaction to be complete, that is why these entities are called as master data. Okay, so that is why whenever we are creating any transaction, so first of all, before creating that transaction, we should have the master data in place. So here you can see that in a transaction, we have different master data, and master data is nothing but different entities which are creating a transaction. Okay, so here you can see that Ram is a component of master data. ABC store is a component of certain master data, apples and displays and so on. So now, if you talk about Ram, then he is actually a customer. Okay, so you can group these entities in a certain name. So Ram is a customer, ABC is a store, uh, and then apples is a product. So we are trying to group different entities in a entity set. Okay. So now again, Chandigarh is, let's say, I mean, we can skip it if you want because anyhow we will take this later on. So for now, we will take this. And finally, this is your time. Now, each of these entities will become a dimension member. Okay. So master data, here you can see that we have customer master data, we have a store master data, we have a product master data, and we have a time master data. And in these data warehouse terminologies, these master data are called as dimension tables. Okay. So we are left with customer dimension, and we have the store dimension, and then we have the product dimension, and finally we have the time dimension. Okay, so here we have the different dimension tables ready, and then once we have specified the different dimensions, here we can see that different dimensions will have different attributes. Okay, so each dimension table, each dimension, here you can see that each dimension will have a set of attributes. Okay, great. So let us try to understand what all different attributes a customer dimension can have. Okay, a customer will have a name, will have an age, will have a phone number, uh, will have a phone number, and then he will have the contact number. Could be his. It's again, it could be an email ID, it could be address, it could be his marital status. Okay, a lot of information will be there. Okay. So you remember whenever you go to a supermarket for a very first time, over there you are handed over with a form where where you provide different details such as your name, your age, your date of birth, your email ID, address, and so on. So all these different information are actually goes to the database in a specific company or a specific supermarket database, and then these are all your different attributes. Okay. Similarly, if you talk about the store dimension, again, the store dimension will also has different attributes. So there will be a name to the store, there will be a location where that store is, and then how many number of employees work there, and so on. Okay. And then you can also see which brand that store is associated to. It could be a Reliance supermarket, it could be Farm Fresh supermarket, it could be any supermarket, 24/7, 7-Eleven, and so on. Okay. And then if we talk about the product dimension, again in the product dimension, a product is going to have a different type of attributes. So it could be what is the name of the product, what is the price per unit, or I can say PPU, which is price per unit of the product, what is the package date, and what is going to be the expiry date for that product, and so on. And it could again be associated to a brand. Okay. So which brand it is associated to, which brand product it is. Because we can have different products, we can have, let us say, breads of different companies or different brands. It could be from Baker's Beer, it could be from Kitty, it could be from any brand you can associate it. And finally, the time dimension is going to help you understand when that transaction actually happened. So it is going to have different attributes, such as it is going to have an hour, it is going to have a minute, second, what is the quarter associated to, and so on. All these details will be there. Okay, so we will understand in deep dive what we said. So now here, what we have done till now is that from a transaction, we have first of all identified the different entities, and then we created a dimension for each entity, and we then try to understand what all different attributes a dimension can have. Okay. So now this is all details we can have related to a dimension. So now we have understood that to create this transaction, we need at least these four dimension tables. So now let us go one by one and fill these dimension tables. So if I go here, and first of all, if I talk about the customer dimension, and let us try to fill this detail. Okay. So here, okay, I have got a message. Can we put day, month here in a time dimension? Yes, we can have a lot of attributes in this time dimension as well. We are just taking an example. We can have day, we can have month, you can have, uh, and there can be a limitless. There, I mean, you can have a lot of information over there. Just like in your customer, you can have more details if you want. So here we are just taking an example of a few columns we can have. Okay. Okay. So if you talk about the customer dimension, here we have a name, we have age, we have the phone number. Okay, phone number is there, and then we have the email ID, and then we have address, and so on. And marital, I will just say MS as for the marital status. Okay, I'll change it. Okay. So now we have this and so on. And let us talk about the next dimension. We have the store dimension, and the store dimension again has a name, has a location, has the number of employee. I am marking number of employees as NOE, and then the brand. Okay. And similarly, we have something called as the product dimension. Product dimension. In the product dimension, we have again going to have a name. We are going to have a price per unit. We are going to have the package date and the expiry date of the product. And then we are going to have a brand associated with it. And finally, we are going to have the time dimension. And the time dimension will have the hour. Uh, it is going to have minute, second, yeah, the quarter, and so on. Okay. Okay. So let us fulfill the details of the specific dimensions we are talking about. Let us say if we are talking about RAM and RAM has specific details. One second, let me shift it a cell down. Okay, here it should be. Oh, okay. Oh, not here. Okay, so it's good. And same for the time dimension. Okay, that's all good. So what we were trying to do is that we are trying to create a record for a dimension table. So so the dimension table or your master data is going to have different set of records inside of it. Okay, so if you consider this to be a table, so this is the header of your table. So the header of your table will have different columns. So we have name column, we have age column, phone number, email ID, address, and marital status. And then this table is going to have different records. Okay. So if you talk about record number one, then here you will have the data about this customer. Let us talk about RAM. So let us say some hypothetical information about RAM. So the name of the person is Ram. His age is, let us say, 21 years. His phone number is, let us say, 987-654-3210. Okay. And then his email ID is ram@gmail.com. And finally, his address is house number 123 for simplicity's sake. And marriage status is single right now. Okay. Similarly, let us create a record for the store dimension. Then we are going to have the similar store. So because we are talking about the store number ABC, so store will be ABC. Location here we actually discussed that it is in Chandigarh. So location is Chandigarh. Again, we can have additional attributes. Let us say which country is it in, and number of employees who work in ABC store. Let us say they are 11, and the brand is, let us say, um, 7 by 9 by 7, 7 by 11. There are a lot, but let us take the Fresh Mart or any hypothetical name. Okay. So they are associated with Fresh Mart supermarkets chain. So this is a chain of supermarket, or you can even specify it as a chain. Okay. And then the country is India. So this is again, we have created one record for this store dimension table. And if I expand it so that we can see the details clearly. Okay, and this one, and finally this one. Let me highlight this. And let us go to the next dimension. Let me remove this. So now in the next one, we have the product dimension. So again, the product dimension, this will be a table in which we have multiple records. So here, if we talk about the product we were talking about, it was apples. So we will talk about the apple product. Price per unit is, let us say, 10 rupees or any currency you can talk about. The package date is, let us say, it came just before few days. So the package date is 25 of 8 and expiry is 25 of 9. Okay. Okay. And then finally we have a brand. So let us say these are related to Himachal apples, can be anything else. Okay. And then finally we can also have the color attribute to this dimension. So here you can see that we can have multiple type of apples, multiple color of apples. So we can have red apples, we can have green apples, we can have golden apples. So here that is where we have a color associated to it. So here, one second, no borders, and then these borders. So we're talking about the red apples right now because in this statement we are talking about the red apples. Okay. So he bought 10 red apples. Similarly, we can also have one more record for the apple. So it will say apple and then its price per unit, which is packet date, expiry date, what is the brand, and we can have green apples or something else. Similarly, we can have more products which are sold. So we can have bananas, we can have pears, we can have even non-fruits as well. We can sell breads. We can have these. We can sell the bakery items. We can sell the face wipes, face wipes, deodorants, and so on. There will be a different products. Okay, because right now we are talking just about one product because we are just focusing on this transaction. Okay. Similarly, we will have a time dimension. So time dimension, we are restricting the time dimension to a specific columns. So let us, for simplicity's sake, that we have the hour as 10, minute as 0, second as 0, and quarter as, this is quarter number 2. Okay. Similarly, in the time dimension, we will have the information right from midnight to all the time. So if I remove this, so your time dimension actually provides the details right from the 00. So it will start from midnight 00 hour. So for that, I'll do this. It will mention that from midnight 00, it will start at midnight 0 before, because if your store is open 24/7, then it will have details like this. It will go all the way from midnight 00 again, and you will have 00, and it will have all the details of each and every second. So the granularity of data we have in this table is every second. So we have a row to specify each hour, each minute, and each second, and so on. It will go all the way up to the 23 hours and 59 minutes and 59 seconds. Okay, so this will cover the entire day. Similarly, we will have we need to have a date as well. I will add the date. So right now we are talking about today's date. If we talk about 28th of 8, so this will have all the dates associated to today. Okay, similarly, it will have, oh, not this one. I just need them to be copied. Okay, so for each and every day, it will have the time information right from the midnight to 23 hours. Okay, so this is all. So somewhere in between, we will have the entry for 10 a.m. Okay, so this is, we are talking about a future transaction because 10 a.m. has not happened yet. So 10 a.m. will look like this. Okay, so this is what we are going to focus on, this one. Okay. Okay, so now here you can see that we have covered all the data. So here you will see that this is all your master data. So these are all different tables we have, and in this different details, we will have different details. We will store the information for different customers. We will have the information associated to the products, different stores, and then different applications. Let me do this. Okay, there is one thing which we need to consider before moving forward. So here, if you look at this, there could be another customer who will be having name same as Ram. There could be a person who will have the same address, because if you talk about the address, same people, two people can also live in the same address. So there is a possibility of duplicating the data. So that is why I have to select a specific key based on which I can uniquely identify a record. So what I will do, I will introduce something called as customer key. Okay. So customer key is actually a automatic generated ID which starts from 1 and which gets automatically incremented by one value. So when next value of customer ID will come, so let us say customer ID 2 will come. So let us say his that is a customer, say um could be me, and let's say his age is, let us say, 30, and then he will have his associated phone number, email ID, address, and so on. All these details will come. So to uniquely identify a record, this you can consider it to be a primary key. Okay. So we need a primary key on a table to uniquely identify a record. Okay. So this is how it looks like. Similarly, we can have multiple stores with the same name because some brands say that we need a store with the same name at different location. So to uniquely identify a store, each and every store, so that is why we need a store ID. So the store ID will be a primary key for this table. Okay. So the first record, it is not mandatory to have these ID columns at 1, 2, 3, 4. We can also start from 100, from 1000, or we can have the ID like this as well, S minus 1 for store ID. We can have C minus 1 for customer ID. So we can really manipulate this information. Okay. So for simplicity's sake, let us take that we are having just the simple identifier. Similarly, for your product dimension, we will have the product ID, and this product ID will serve as the primary key of this table to uniquely identify each and every record. And let us say the red apples have primary key ID for the product dimension as 1. Similarly, your time dimension will have something called as time ID, and time ID is going to help you understand all to uh, here you can see that. So we need a key which is helping you to identify each and every record. So here you can see that we can create a time ID based on the pattern. We can have Y, MMDD, HH, MM, and SS. Okay. So this format we can use to create a time dimension or the time identifier for the time key, which is going to be your primary key for this table. Okay. So because we are talking about one day, so Y, it is 2023, and then HH, and then MM, and then SS. And the second primary key for this pay table will be Y, and then MM, HH, MM, and SS. Similarly, we will go all the way for one day for the last time primary key ID for this day. Okay, so we will have not just the details. Oh, sorry, I think I missed some information. So it is going to be Y, and then month 08, and then it is going to be 28, and then HH, MM, and 01. So this is your entire primary key. Okay, this has become some really huge information. So I want it to be a text. So this is your first time primary key. Okay. So similarly, this will be the first one, and the next one. Oh, this is for 00. Everything is 0 because it is midnight, and then we have 01 for the next one, and so on. For the last key of the day, we will have information like we will have Y, and then mm, and then dd, and then HH. Hours is 23, minute is 59, and second is 00. Okay, so here you can see that, oh, it will go up to 59, 59. Okay, so now we have the complete day covered. And if you're talking about the 10 a.m. of today, then the key will look like 2023, and then okay, it is going to be, okay, mm. Okay, I have, okay, y, mm, and then dd, and then it will be 10, 00, 00. Okay, so this is the key which we have created. Okay, I need to add the text. Okay, so so this is 10 a.m. of today which we are talking about. Okay, so this is how we have generated a unique identifier for each and every row within the time dimension. And now what we can see is that we have a primary key associated to each and every table, so that just in case if we have any other customer or any other product or any other store, uh, so we can identify that customer very easily. Okay, so now we have the primary keys. So this is your primary key, and then once we have defined the primary key, we are now ready with creation of the transactional data. Okay, so here, this is how the step happens. This is how the steps we have. So first of all, we have to identify whenever we are going to create a data warehouse from a scratch. So the very first steps we have to do is that we have to identify the different entities. Okay, so what all entities are going to play a role in my warehouse and or in my data warehouse. And then first of all, we have identified the entities. Then we have to identify the different attributes we are going to store in the data warehouse. So first of all, we have identified the attributes. Then we have to populate the uh, we have to populate the sorry populate the records. Okay, records in the master data. So your master data is similarly to your different dimension tables. So all these entities and attributes are related to your master data. Okay. So now we have the master data ready with the data. So here you can see that we have the master data associated with the customers, to products, to stores, and time. So now once we have populated the master data in the tables, the next step is to actually populate the the transactional data. Okay. Okay. Transactional data. Okay, because the transactional data makes no sense if you do not have a master data. Here you can see that this is one of the transactional transaction we are talking about. So if you do not have information about the master data or different dimensions, we will not be able to create a transaction. Okay, so now let us create a transaction data. So transaction data is, this is your transaction data. So this is what we are trying to create. So I will create a record for the transactional data. So let us see how many records it is going to have. So here, this is your transactional data. Once again, or transaction data will be in your transaction table. Okay. Okay. So this transaction table actually summarizes the information from multiple master data table in one place. Okay. So right now, here you can see that we have different master data. We have the customer, we have store, we have product, and we have time. And all these different dimension members are referred in your sales transaction. So one of your customer dimension member is Ram. He is referred in the sales transaction. We have the uh, store attribute or a store member EBC, which is referred here. And we have the product attribute or product record, which is referred over here, and time as well over here. So that is why we need to refer the data from multiple master data into the transactional data. So here we will, first of all, if we want to refer the customer dimension, we will have to create some IDs. Okay. Because we do not want to store the entire information in one place. So we will refer the dimensions, or we will refer the master data to transactional data using the IDs. So we will have the customer ID, we will have the store ID, we will have the product ID, we will have the time ID, okay, TID. And similarly, once we have taken down all the different dimensions we want to populate, on top of that, the transactional table will have additional, what you can say, additional measures created on top of it. So here we can say that how much quantity was sold, what was the total price of the transaction, okay, or we can have how much sales happened and what was the profit generated from this sale. Okay, so but one thing we have to understand related to the transaction table is that these transaction tables will always contain numbers information. Okay, whether it is your identifier or whether it is your the different measures we create. So these are multiple measures we have created just for this transaction table. For more details, and here, wherever if you talk about the master data, which are your different dimension tables. So master data can have either numbers, here you can see that this is number, this is a number, or it can also create a known number for columns as well. Okay, so just like we have this one, we have the email ID, we have address and marital status. Whereas your transaction tables are only going to contain numbers. So let us talk about one of the record we are going to create. So here we have, if you're talking about this customer, so we will say customer ID 1 came to the store ID number 1 and he purchased price product ID 1, and what is the time he came at this time. Okay, so this is the information we have. Okay, so if we talk about customer ID, if you want to say that customer, which customer came, so we have customer key 1 associated to Ram. So we will say customer ID 1 came to the store. So if I say customer ID 1 came here, so here you can see that if you see it like this, so we will have a link from this customer ID to this customer key. And then similarly, we have the store ID link to the store dimension. This is your coming from here. And then your product information is coming from here. And finally, your what is left, you have time dimension key. The time is coming from here. Okay, so this one. Okay, so now here you can see that we are referring to the primary key of the dimension table from the transactional table. So here, this is your primary key, but in transactional table, you will have referential key. So your customer ID here is a referential key, which is referring to the primary key of your customer dimension. Okay. So your transactional table, first of all, it will have a numbers only. It will have the data type as numbers. And again, it will contains referential keys. Okay. Referential keys. Okay. Referential data will be here. The referential data will be coming from master data. And on top of that, we can also create some additional measures on top of it. These measures will not be coming from somewhere, but these will be some calculated columns we need to perform or to understand the entire transaction. So if we look at it closely, so here we are talking about the customer ID 1. So here we can see Ram. And if we talk about store ID 1, it is talking nothing about store ABC, which is located in India, which is associated to a chain. And then we have a product. We are talking about red apples over here. And then this is the time which we are linking to. And now here we can see that what is the quantity. So here if we go back to the transaction information, we can see that this transaction consisted of buying of 10 red apples. So we will have this transaction consisted 10 quantity, and sale is coming from the sale is actually a calculated column. It will come from how much quantity and how much is the price per unit. So it will, the total sale is the price per unit into how many quantity of products you purchased. So because this person purchased 10 apples and each apple is worth 10 rupees, so that is why the sale is 100 rupees. Okay. Then this profit column will be internal to your organization or your departments or your supermarket. Let us say from the total sale they have done for every purchase of a particular product, they make 20% in profit. So with this transaction, they have 20 rupees as a profit, which is generated by that. Okay. So this is all information we have. And similarly, we can also have a primary key associated to the transaction table, because there are going to be a lot of records in your transaction table. We might also need to consider that we will have a primary key associated to your transaction table just to uniquely identify each and every record. So it will be transaction ID. So this will be transaction ID 1. Okay. So this is your entire transaction table, which has been created now. So here, if I redraw this diagram, so here you can see like this. So we have a customer dimension. So if I say this customer dimension, and then we have the product dimension, and then I have the store dimension, okay. And finally, we have the time dimension, okay. And then, okay, within these dimension, inside it, I have a transactional table or a fact table, okay. So this transactional table, which we have discussed over here, this transactional table is also called as a fact table, okay. So again, the properties are going to be the same. So fact table has different referential keys. On top of that, we also can have additional calculated columns produced on top of that. So here, the fact table is in between, and it is referring back to your multiple dimension tables. Okay, or a master data. So here, this one, and similarly, okay, this one, and finally your time dimension. So this is how the image looks like. This is what we have created. And then we have the fact table in between, which is referring back to multiple dimension table. Each dimension table is having its own primary key, and from the fact table, we are referring to the different keys by using a referential key. Okay, so this all goes here and this goes here as well. Okay. Okay, so now if we talk about, so this is the structure which we have created. Okay, this is just a recreation of this above statement where we have the arrows going from one place to another place. So this is one structure which we have created in our data warehouse. Okay, so now this is actually called a star schema. Okay, so if you are having a data in one place where we have a fact table, you can also have multiple fact tables, but in this case we have only one fact table which is referring back to multiple dimension tables. Then this setup of data or different tables, so all these are tables, so your customer dimension is one table and so on, all even your fact table is these all tables which are related, which are associated in this format, in which you have a fact table in the center and you have different dimension tables surrounding them and linking back to them. This is called a star schema. Okay. Okay, so first question comes that why do we need to create this kind of information in one place? Why do we actually need to create these link ups and everything? So now, if you see, anyhow, if you might have considered this thing, that then your one transaction ID, TID1, is nothing but a representation of this transaction from where we started. Okay. Now, if I want to do any transactional or if I want to do any analysis on the data, I can do the analysis right away on this fact table. Okay, I do not have to unnecessarily go to each and every dimension table because all the information is available to me in one table. So this table can be used for different analytical purposes. So if you want to see how many sales has happened in day, so we can group by on the tree ID and we can do the count of transactions which has happened, and if we want to see how many times the specific customer came within a month, then we can do this from here as well. Which store is doing most of the transactions, we can do it from here. Which product is being sold maximum amount of time in the specific period or a specific quarter or a specific year, we can see that from there as well. How much quantity has been sold for us in a specific transaction, which customer is doing most transaction in this table, which customer is buying which products together, how much profit we are making for each and every customer. So many decisions we can actually take from just one table rather than looking up multiple tables and trying to find the relationship between them. That is why this fact table is going to help us a lot, because all the information from multiple tables has been brought together, and on top of that we are also created multiple measures which are going to help us understand the detailed insights of a specific transaction. Okay, so whether you call it transaction table or you call it fact table, it is same thing. Okay, so this is your star schema, and similarly there could be a possibility. Let us discuss about one more possibility. So if we talk about the store dimension, it can be applicable to any dimension, but right now we are talking about this one. So let us take this dimension table and try to understand some more details about it. Okay, so now this is your store dimension, and similarly you could have some more stores coming up in the same location. Okay, so there is, let us say, DF store, GHI, JKL, MNO. Okay, a lot of stores are coming up in the same location, and it could be having multiple different number of employees working here. Some could have 20 because they are large stores. Some are stores, small stores, so they could have less number of employees, 670, and then 17. The 27 is a lot. And then they could be associated to same chain or different chain. Let us say they are Connie Marts and so on. They have Reliance stores and so on. Maybe this is also Fresh Mart, Fresh Mart. And all these stores are again available in the same country. Okay. It could be available in multiple countries. So for now, let us consider that these all stores which are opened for a specific chains, these are all available in the country India. So here, as you can see that as the table is growing, we are storing some specific details which are repeating multiple times. So we have this location being stored multiple times. We have country being stored multiple times. So let us see how we can deal with that. So now what we usually do if we do not want to store a specific detail multiple times, so we can break this table. Okay. So here we are talking about the normalization concept. Okay. So we are talking about the normalization concept in which if we are having the information available in one place, and if we want to make your table smaller or make it to make more sense, then what we do is that we do break that table. So now because the location and the country is repeating multiple times, so we will take this information in a separate table. So let us do one thing. Let us take the location out of this table and this country out of this table. Okay, and place the other two dimensions together. Okay, so now what we are saying is that we will take this. So this is your new dimension, store dimension, and this is your new location dimension. Okay, okay, that's good. Now what will happen is that we will have an additional record. Similarly, what a relationship we have seen between the fact table and the dimension table, similar concept we will create over here. So this is your store dimension. So you will have different store IDs. They will go like this. Okay. Field series and so on. We will have 5. So now if this is your store dimension, what I have done before, because the information related to the country and location were getting repeated multiple times, which we do not want. So that is why what we will do, we will create another table with the name of, let us say this is your location dimension, not the location. Yeah, location dimension will work. Okay. And then this location dimension will have the location key. And similarly, it will be having only one record because all these records are same. So I do not have to create this record 5 times. It is fine if I create just one record. Okay. Unnecessarily, I do not want to waste a stage space to store the similar data. So that is why we have only one location. So that is why only one location ID will be there. Okay. Now I have location key, which is primary key for this table. And then this primary key will be referred in the this stored dimension table. I will add one record which will have the location ID, and then it will be a referential key to the location dimension. Okay, so this is how it goes. So we have something like this. Okay, so the location ID in this table will be one for each and every record, because anyhow all these stores are associated in this Chandigarh location and this country ID. Okay. So instead of saving the location Chandigarh 5 times and location country India multiple times. So what we have done is that we have separated this information in another table, and we are looking up it from the products from your store dimension. Okay. And then here you can see that we have a link like this between these two tables. Okay. So we have only one record. So just in case if we are also introducing one more location, so we will say location key 2. So let us say this store is also opening up in Bangalore or Bengaluru, Bangalore, and then it is again in India. So what we will do, if a new store is opening up in Bangalore, we do not have to store these details anymore. So we can say that the store ID 6, then let us say JKL will be there, and then number of employees is very big store. So let us say 30 people work there, and it is for the fresh marts, and then the location ID will be 2, because this store has opened in your Bangalore location. So that is why we have a link coming up. So this column will be your referential key, and then this will be your primary key for this table. Okay, this location key is actually your primary key associated to your location dimension. So if I try to draw this break of this table, so here we can really well understand that your store dimension is again segregated or again breakdown into a location dimension. Okay, so you have the location dimension, and your store dimension is linking to your location dimension for complete information, as we can see over here. So this is how it looks like. And we can similarly break down the customer details as well, because we can have different type of customers. We can say give the loyalty table, which will actually help us understand what type of customer is that, whether that is a platinum customer, a gold customer, silver uh, club, or so on, so that we can actually group the customers in a specific domain, and based on that we can give them a specific uh, you can say specific promotional offers or specific discounts for these customers. Okay, so we can similarly have the loyalty customer table, which will help us group the table, because anyhow we will have 3 or 4 different types of loyalty rewards. So that is why it makes sense to store it in a separate table instead of having the duplicated data in the customer dimension, because the customer dimension can have a lot of records. So I do not want to store these 3 or 4 specific details in one place. So I'll link up this from this. It can be similarly for the location as well. Um, in the product as well, we can again have a class created. So these are all bakery items, these are all fruits, these are all vegetables. So we can have um, the category, or the product category. Okay. So this is product category. Similarly, we can have this category column, which will again, I will repeat, this will help us to group the different products together. So we will have a link from here to here. And similarly for time dimension, I mean, we specifically do not need to store the data for a time dimension, because anyhow, all the records are already unique in your time dimension. Okay, if you see here, only the quarter is getting replicated, but because this is a very small integer data, so it is not going to hamper the storage at all. Because anyhow, if we create another table for this, it is going to take additional storage. Okay, so let it be like this. So now it is not just one table. We can also break a table into multiple tables as well. So here, if I talk about, if I have the table, if I have different locations, so let us say if I have store number 3, store number 4, it is in Hyderabad, it is in, let us say it is in maybe some other location, Kolkata, I don't know. And in all these tables here, you can see that the column country is being repeated. So instead of this, what we can also do, although this is not required, we can create another table which is called as country ID. And over here we have the country name. First of all, we will have country key, we'll have the country name, and so on. Okay. So now, instead of saving the country India in this table, we will actually store it only once in this table. Okay. So but here, instead of saving the country name, we will refer it to country key. Okay. Then we will have only one record. We have country key 1 associated to country name India. So instead of writing India in this place, I will just save 1 over here. So this is similar to what we had done over here. So this will be your country dimension. And then we have all these dimension being looked up to each other. Okay. So this is how it goes. And then here we have created the relationship between the customer key and the customer key of this location dimension to the country key of your country dimension. Okay, so now here you can see that your if you talk about the store, first of all we have the store dimension. The store dimension is having information from the location dimension for a specific location, and it is having a country dimension to get the information for a specific country. Okay, so here we have location dimension, then we have, what one was that? We have location dimension, and then location is going to the country dimension. Okay. So there is no restriction of how many levels of dimension tables you want to create. Dimension. So here you can see that the store dimension is actually going to multiple dimension tables. So to get the stored information, first of all, you will go to the fact table, and from fact table, you will come here. If you want to know the location, you will come here. If you want to know the country, you will come to this table. So all these tables are related to each other using the primary key and referential key constraints. Okay. So similarly, this can happen for multiple tables. It is not mandatory. So you can say that the time dimension is having 0 steps. Product dimension is having 1 step. For customer dimension, we have 1 step. And for store dimension, we have 2 steps. Okay. So if I want to redraw this diagram, so it is not a star schema anymore. Okay. So if you have a setup where your dimension table is further split into multiple tables, this is called as the Snowflake schema. So don't confuse it to Snowflake data warehouse. This is not specific to your Snowflake data warehouse. This is just a concept associated or related to your this, what is that? The data warehouse. Okay. Snowflake dimension. It is just the name is matching. Okay. So let me show you one more really nice diagram with which you can really well understand why they are actually called as star schema or a Snowflake schema, so that you do not forget that. So if I go here, so if I say star versus Snowflake schema, then just looking at the images, you will come to know why it looks like that. Okay. So here you can see that this, if I zoom it a little bit, so here you can see that first of all, we talked about the star schema. So star schema is a setup of different tables. So all these are tables, your fact or measure is your table, and we have different dimension tables. So your fact or dimension table sits in the middle and it links to different dimension tables using primary key and secondary key relationships. Whereas if you talk about the Snowflake schema, in the Snowflake schema, the setup is same. We again have the fact table or the your transactional table in the center, and it is linking to the dimension table, which are again split up into different dimensions. Okay. Just in case of your the product dimension, we have the product dimension, we have the country dimension, and we have a store dimension. Okay. Sorry, we have not associated the product, but it was for stores. We have store dimension, we have location dimension, and we have a country dimension. So it is not mandatory for all the dimensions to have the similar levels of breakdowns. So we can have one for someone, we can have two, we can have three, we can have four. But if your dimension tables are splitting up into multiple dimension further, then they are called as Snowflake schema. This is what we have seen. And if you look at one of the example, which can be over here. So, okay. So first of all, if we look at a star schema, then we have a fact table in the middle, and it is surrounded by a different dimension table. So here we have time dimension, we have people dimension, we have geography dimension, and a product dimension. Similarly, if you talk about the Snowflake dimension, your dimension table may or may not get split up into multiple additional tables. So here you can see that the people dimension is not split up. Your store dimension is split up into location dimension. And if we talk about the product dimension, your product dimension is similarly broken down into brand dimension and category dimension. Your date dimension is split up into month dimension and quarter dimension. Okay. So these are the major type of dimension, major type of schemas we have. We also have different type of schemas, but here these are the most important ones we have within our data warehouses. Okay. So we have understood that the whole purpose of creating these Snowflake dimension, sorry, Snowflake schema, it is not Snowflake dimension. So why we need to create, first of all, we understood what is a star dimension. So star dimension we have seen, and we have the Snowflake dimension where the one dimension is being splitted into multiple dimension. Okay. Okay. So anyone has any questions, please let me know. Till now, is everything fine? Everything okay? Are you getting it? Or if you have any questions, please let me know. Oh, where is my oh, where is one of the
Hey,
dimension?
Vipul.
Yes, hi.
Hey, I have one question,
Yes,
right?
Vivek.
We
Yes,
have
sure.
defined this star schema, right? Customer
Hmm.
dimension and all that, right? Now,
Right.
how will receive the data to load that? So the customer, I say store is a static data, right? We have a
Mhm.
file store, so we first time master entry we can do that, right? But how the fact table will get the data and dimension that files? How the files we will receive different files from the different stores? Suppose we have a two stores, right? So that can you cover on that page?
Sure. So let us say that we are maintaining a simple. Oh, one second. Let me. Oh, have I copied this? One second. I think I took it from there. So just a second. I think I
Yeah, no problem.
cut pasted this one. I will take this
Can we
over
get this
here.
file actually?
Yeah, yeah, sure, sure. I will provide this in. Are you in the WhatsApp group? I will
Um,
provide this over
which
here.
WhatsApp group actually?
Uh, the
See, I
KSR
got the
data.
link from one WhatsApp group. This only
Yes, yes, yes. This is. Yeah, this one.
KSR software. This soft
KSR ADE.
Snowflake WS session, right?
All right. Yes, yes. Oh, yeah. I will drop it there. Okay. Not a
Yeah.
problem. Okay. So now let us redraw this diagram, what we are looking at. So let us consider a simple star schema. So if I draw like this, and if I have the similar shape. So this shape will not be there, just to make you understand how it looks like. So if there is
Then
any
just
star. Okay. So first of all, we will have a fact dimension in the center. So it will be a fact table.
yes,
And then we will have different dimension table. We will say, let's say any dim1, dim2. These are all dimension tables. And then we have dimension 3 and we have dimension 4. Okay. So once you have defined this structure, then of course we need to bring the data from somewhere. Okay. So this data can come from different sources. It could be from a different databases. So it is possible that you have a system, because see, this is a data warehouse. Okay. So data warehouse is not going to produce any data. Okay. So it is going to have a data from somewhere. So there could be a legacy database, which we discussed in the last session, legacy database, over where this, which let us say there are different systems. We have here, if you look at the day one, so if we have different applications and which is having the customer data, sales data, finance data, section data, and region data being stored in different databases, let us say. Okay. Then what we can do is that if you want to migrate your legacy database data into your data warehouse, so what we can do, if this dimension 1 is your customer dimension, then for that we can do like this. We can take the data from your customer database into your dimension 1. So all the customer data which is available in this legacy system of the customer table, it will be brought in your dimension 1. It could be done using an ETL tool or using your different files. Okay. So it all depends of how you want to move the data. If you have an ETL process, we can do that, which we had seen. Whether you can have an ETL tool or you can move the data here. These are the two concepts we can use to move the data. Okay. So within the Snowflake data warehouse, we have created the star schema, and to populate the tables, different dimension tables of a table, we can either bring the data using an ETL tool or using ELT technology, in which we are first of all extracting the data from a source database into an S3 bucket, and then that S3 bucket file will be consumed within your Snowflake data warehouse. Okay. So we can populate instead of ETL or files, I can say that either you can take ETL approach or ELT approach to populate one by one tables. Similarly, your dimension 2, let us say if this is having the customer data, oh sorry, that is already covered. So if it is going to have the finance data, uh, these sales and transaction are the same. Doesn't make a difference. So this sales and this transaction are the same. So I'll just remove sales. Instead of sales, I will say the products. Okay. So the product information, let us say it will go to the your third dimension. Here it is. And anyhow, we do not want to bring the time dimension from somewhere. We can create it inside of it. So it is not a problem. So that is how we can populate the different dimension within that. And once we have different dimension tables being populated in the data warehouse, and then finally we will bring the data for the transaction. Okay, so we will finally bring the transaction data in a fact table. Okay, so similar concepts will be there, and then we will have the complete Snowflake schema being created in our Snowflake data warehouse. We can also go for different schemas. We do not just have star schema and Snowflake schema if you want to deep dive. Okay, so any questions? Anyone else? Okay, then have a great day. Hope you enjoyed the session. We will meet tomorrow, same time, 7 a.m. IST. Have a great day. Bye bye.